In this video, we talk about the technique of integration by parts. That's a technique that is used for some functions to integrate, and these are the functions that the substitution is not sufficient to find the antiderivative or the integral of the function. Before writing down the formula for the integration by parts, let me give an introduction. As you might remember from Calc 1, you know that if we have the product of two functions, for the derivative, we have the product rule. So suppose u of x and v of x are two functions of x. For simplicity, just let me write u and v. So to be more accurate, u is u of x and v is v of x. Or if the variable is t, u is u of t, v is v of t. And you know that the derivative of this product, by using the product rule, this is u prime times v plus u times v prime. So this is a reminder about the product rule that we had in the in calculus 1. So now let me keep this on one side and subtract this term from both sides. So let me write uv prime first. So I will have uv prime on one side and uv all prime minus u prime v on the other side. So I just kept uv prime on one side and uv all prime minus u prime v on the other side. Now I integrate both sides. The integral of uv prime equals the integral of uv all prime dx minus the integral of u prime v dx. You know that integral and integration and differentiations are the converse of each other. So uv prime, then taking the integral, gives me back uv. Or to be more accurate, uv plus a constant. But since we have another integral there, we don't need to worry about the constant here. So in fact, this is the formula for the integration by parts. But of course, if it's the first time you are seeing that, it might look like a little bit strange unless we see some examples and see why it is helpful. So let me write down the formula for the integration by parts. So u times v prime dx equals uv minus the integral of u prime v. So that introduction here was all for this formula, the formula that we have for the integration by parts. So this is the formula that we use to find the integral of some function using integration by parts. As I mentioned, this is not clear unless we do examples and see that how this formula is helpful. So let's see this example. Evaluate the integral of x times cosine of x. And I want to type in the answer at the end here. If you try the substitution, you wouldn't get anywhere. This is not an integral that we can do by using substitution. Of course, we can try to see that why the substitution is not working here. And we haven't seen in Calc 1, you haven't seen any integral like this, that x times cosine. You have seen integral of cosine of x or cosine of something times x, or maybe things that you can use the substitution, but not this one. This one cannot be done with using the substitution methods. That's where the integration by parts come into play. So let me rewrite this integral one more time here. So the integral of x cosine x dx. And you will see how by using integration by parts, this is going to be solvable. I take this as the function u of x, or u, and this as v prime. So let's see what we have. U is x, and u is x, therefore u prime is 1, right? And v prime is cosine of x. If v prime is cosine of x, what is v? The easiest v that we can have is sine of x. Of course, sine of x plus a constant, but to keep it simple, just go with sine of x. So if v prime is cosine x, v is sine x. Now, let's take another look at the integration by parts. Integral of u for v prime is uv minus integral of u prime v. So this equals uv. What is u? U is x. U is here. What is v? V is sine x. So that uv is going to be x times sine x. Minus what? Minus the integral of u prime v. What is u prime? U prime is 1. What is v? V again is sine x. V here is sine x. 1 times sine x. So 1 times anything doesn't change the function, so it is the integral of just sine of x. Just clarification here, it is x times sine x. Okay, what is antiderivative of sine? It's going to be minus cosine, right? So what's the final answer? X sine x, negative, negative, 2 minus, make a positive, plus cosine x, plus c. So by using integration by parts, we're able to do this integral, and the answer is going to be x sine x plus cosine x, and then at the end plus c. So the idea of using integration by parts for this integral was helpful because this original integral was rather complicated. But on the other side, we got an integral which is much more simple, right? So by using integration by parts, we're able to kind of simplify or make the integral more simple. Before doing the next example, I want to remind you something from substitution, uh, just as a reminder. As you know, using substitution, like something like integral of, this is by using substitution, integral of sine of 2x. Do you remember how we dealt with this using substitution? We let u be 2x and we solve the integral. At the end, we get minus 1/2 cosine of 2x plus c. There is nothing special about 2. It could be any other non-zero coefficient. So if we use substitution, in general, we have this helpful integral that is helpful formula for the integral that sine of kx is going to be minus 1 over k cosine of kx plus c. And in a similar manner, as you have seen by using substitution, integral of cosine of kx. If I use the substitution u equals kx, I get this formula. So these two are two helpful formulas. If we keep this in mind for these two types of integrals, we don't need every time to use substitution and find the answer. So by using substitution, we can get these formulas. Like for both of these two, the simple case was when k is 1, like integral of sine of x is minus cosine x, and integral of cosine x is sine x. But if there is a coefficient involved, like k in general, that's the formula that we can obtain by using substitution. The reason I mentioned this is because in the next example, this formula, at least one of these formulas, will be very helpful. Let's go to the next example. The example is by using integration by parts. I want to find the integral of x times the sine of 5x. So please try this on your own. Pause the video. Try to do this on your own and then watch the rest of the video to see that if you get the same answer as I did or not. So for this integral, let me rewrite it here, x sine of 5x. If you want to use integration by parts, what do you take as u and what do you take as v prime? So as you might have correctly figured out, this will be u and this will be v prime. So if u is x, u prime, the derivative of x is 1, right? If v prime is sine of 5x, the easiest antiderivative or the most straightforward antiderivative of sine of 5x, in other words, v itself is minus 1/5 cosine of 5x. So in fact, here I used this formula. As I mentioned here, and at this step, we don't need plus c because at the end, we use a plus c when we answer to an indefinite integral. So now this integral becomes what? Becomes u times v. This is u, this is v, x times minus 1/5 cosine of 5x. So it's going to be minus x over 5 cosine of 5x minus integral of u prime v. Again, we are using the integration by parts formula. So here, the integral of u prime v. This is u prime, which is 1, and this is v. So 1 times minus 1/5 cosine of 5x dx. Minus 1/5 has been multiplied by cosine of 5x. It's a constant, can be pulled out of the integral. So what do we get here? We get minus x over 5 cosine of 5x plus 1/5. Negative 1 times minus 1/5 makes a plus 1/5. Integral of cosine of 5x dx. But what is antiderivative of cosine of 5x? That reminder will be helpful here. Integral of cosine of kx is 1 over k sine of kx. So here it's going to be 1/5 sine of 5x. So in fact, in this problem, we used both of these two formulas for finding the integral of sine of kx and cosine of kx. So now what's the final answer? So the first term is here, minus x over 5 cosine of 5x. A 1/5 times 1/5 is what? 1 over 25, right? Times sine of 5x. And don't forget plus c at the end. So let me repeat the final answer in this box on the top. So minus x over 5 cosine of 5x plus 1 over 25 times sine of 5x. And at the end, plus c. Let me write down an example which is very similar to this and try this on your own. And that is the integral of x times the sine of. In the previous example, the coefficient was 5. Let me make it 1/5. 1/5 times x dx. So that k, that coefficient of x in the previous example was 5, but in this example, it's 1/5. So please try this on your own and then watch the video to see that if you got the same answer or not. Again, let me rewrite the integral x, the integral of x sine of 1/5 times x. What did you take as u? So this is u, and you probably took this as v prime. So u is x. u of x is x. In other words, the derivative of u is going to be 1. And v prime is sine of 1/5 x. What is v? Do you remember here this formula? Antiderivative of sine of kx is minus 1 over k cosine of kx. In this example, that k is 1/5. So minus 1 over k, minus 1 over 1/5. And 1 over 1/5 is 5, right? So that's why here we see 5. In the previous example, that v was minus 1/5 because k was 5. But in this example, k is 1/5, so 1 over 1 over 5 is 5. So minus 5 cosine of 1/5 times x. So let's see what happens to this integral. This is going to be u times v, x times minus 5 cosine of 1/5 x, which is minus 5x cosine of 1/5 x, minus integral of u prime v. U prime is 1, doesn't do anything, and v is minus 5 cosine of 1/5 times x, and then we have dx. So let me separate the solution from the left side of the board. Okay, so the first term minus 5x cosine of 1/5 x. This minus 5 can be pulled out of the integral, and minus 5 times that's minus outside the integral, they make a positive 5, right? So I will have positive 5, the integral of cosine of 1/5 times x. Uh, what is the integral of or antiderivative of cosine of 1/5 x? Pay attention here that k is 1/5, so 1 over k is gonna be 5. So that's gonna be 5 sine of 1/5 x. So in fact, it was using the formula that I mentioned before, that coefficient is 1 over 1/5. And 1 over 1/5 is 5. Okay, so we are ready to write down the final answer here. The first term, minus 5x cosine of 1/5 times x. What is the coefficient of the second term? 5 times 5. They make it 25 here. And the function after 25 is sine of 1/5 x. And at the end, plus c. It's an indefinite integral. We need a plus c here. So let me repeat this final answer. Inside this provide the space. Minus 5x cosine of 1/5 x plus 25 sine of 1/5 x, and at the end plus c. Okay, now let's see an example that the exponential function is involved. And I want to use the integration by parts and find the integral of x times e to the x dx. So as usual, please try this on your own before watching my solution. Let me repeat the integral here, x times e to the x. This is not an integral that can be done by using the substitution. And we need to use the integration by parts. So let's take this as u of x and this function as v prime. So u is x, therefore u prime is what? V prime is e to the power of x. Do you remember what was antiderivative of e to the power of x? It is again e to the power of x. So this integral using integration by parts is u times v. This is u, this is v. So x times e to the power of x minus the integral of u prime v. U prime and v. U prime is 1, doesn't do anything, times v. V is e to the power of x. Antiderivative of e to the power of x is itself e to the power of x, and of course a plus c at the end that we keep it for the indefinite integrals. So the final answer is going to be x e to the power of x minus e to the power of x plus c. So let me repeat this final answer here, x times e to the power of x minus e to the power of x plus c. Before seeing the next example, let me remind you something from substitutions that will be needed for the next example. As a reminder, you know that if we had the integral of e to the power of a constant times x, like e to the power of 3x. As you might remember, by using substitution, this is going to be 1/3 e to the power of 3x plus c. Nothing special about 3. It could have been any other constant, of course, except 0. So if I have the integral of e to the power of kx dx, so where k is a constant other than 0, it's just a constant number. Then this is going to be 1 over k, the integral times e to the power of kx plus c. This is the helpful formula that is obtained by using substitution. So just let me keep the general form of that reminder. So k is a constant, but definitely it's not 0. The reason that I mentioned that is because that's helpful in the next example that we have this integral that we want to do the integration by parts and find the antiderivative 2x times e to the power of 3x dx using integration by parts. Please try this on your own. I would suggest pause the video, try on your own, and then compare your final answer to the answer I'll get in a few minutes. So let me repeat this integral here. Excuse me. So the integral of 2x e to the power of 3x dx. I take this as u and this as v prime. So u is 2x. If u is 2x, what is u prime? The derivative of 2x is just 2. And let's have v prime to be e to the power of 3x. What is v? Using that reminder that we had here, antiderivative of e to the power of 3x is 1/3 e to the power of 3x. Now this makes our integral much more simple. So this is going to be uv. What is u? U is 2x and v is 1/3 e to the power of 3x. So 2x times 1/3 e to the power of 3x, which is 2/3 x times e to the power of 3x. Minus what? Minus u prime v. U prime is 2, right? And v is 1/3. So the integral of u prime v, 2 times 1/3, which is 2/3 e to the power of 3x dx. So 2/3 x e to the power of 3x. That 2/3 is a constant here, can be pulled out of the integral. So minus 2/3, the integral of e to the power of 3x dx. Now, what is the antiderivative of e to the power of 3x? Again, by that reminder that we had here, this is going to be 1/3 e to the power of 3x. So what's the final answer? So 2/3 x e to the power of 3x. 2/3 times 1/3 makes it a 2/9, right? And e to the power of 3x plus c. Let me repeat that final answer here. So 2/3 x times e to the power of 3x minus 2/9 e to the power of 3x plus c.